And Fionnán is his presentation is today titled Cloud Solutions and what the regulatory guidance bodies are saying. So we'll get into that. Fionnán is Head of Business Solutions and co-founder at Odyssey BC. He has worked for over 2 decades as a computerized systems validation consultant in the life science industry. He has spent most of the time working as lead consultant for a diverse range of projects, including leading full CSV lifecycle implementation on greenfield pharma and biopharma sites. He has extensive experience in assessing and auditing GXP system setups to ensure high levels of compliance. So thank you so much, Fionnán, and you're perfectly positioned to let us know what you're hearing from the regulatory and guidance bodies on this whole topic.
Okay.
So you could just share your screen when you have a moment.
How's that?
Yes, that's perfect. Thank you so much.
Okay. Good afternoon, everybody. My name is Fionnán Friel, and I'm the Head of Business Solutions at Odyssey Validation. So today I'm just going to be building on what Oisin has talked about and in relation to what the recently released regulations and guidelines are stating on the topics, just some high-level key points, because the new, I'll be talking about CSA and GAMP 5 edition 2, which is quite large. There's a lot in it, but just picking out some salient point. These new regulations and guidelines, they apply, or you should be interested in hearing what they might say, whether you're a software supplier currently, or if you're looking to be one into life sciences, or if you're a life science company looking to select a product or supplier and you're looking to get some kind of guidance on all of that.
So Fionnán, sorry to interrupt you. I'm not sure that your slides are moving.
How's that?
Yes, that's
okay, great.
Thank you so much.
Okay, so we're going to look at CSA. As we all know, we've been waiting for quite a while for it to be finally released. It's over 2 years now, maybe longer, and it's just recently got released on the 13th of September. So we'll have a brief intro to CSA and how that leads up and what they might saying about software suppliers. And then we'll touch on GAMP 5 second edition again with a very brief intro and more focus on what the changes they have in there in regards to suppliers. Okay, so CSA, the scope, it's intended to provide recommendations regarding computer software assurance for automated data processing systems that are used as part of production or quality systems. So they're saying it's really systems involved in production of products and systems involved in the quality around products as well. So what they're doing is out of scope for systems that don't have any impact on that, like your email, et cetera, et cetera. It's called out clearly in CSA. It's there to address, number one is outline and clarify on risk-based approach, what that means for them. It's always been there for us. So risk-based approach is nothing new for people who work in the life science industry, but for software suppliers, it's something maybe that they have to get involved in and get used to. And secondly, it's going to outline methods and testing activities that are linked to that risk-based approach. And that's probably where the biggest change is within that CSA introduces into the world of the computerized systems validation person in the industry. Okay, so fit for intended use is still there. It's a life cycle that includes how you conceive, design, test, and release. And they talk about a least burdensome approach to validation. Just doing that, what's necessary to address risk. So it's a risk-based approach for establishing and maintaining confidence that software is fit for intended use. Same terminology, and that's always been the case in life science industry. What is the level of effort and the level of assurance that you need to put in place? So what they're saying is risk of compromised safety and or quality equals the level of assurance, effort, and activities appropriate to establish confidence. Like that in itself isn't a wildly new statement, sorry. Lots of companies have been taking risk-based approach for years. They have been doing the right amount of testing at the various stages through factory acceptance testing, site acceptance testing, and then testing on site. So that in itself is not something that's very, very new. And neither is the next bullet point, which is about the maintenance. So software needs to be maintained in a valid state and should perform as intended throughout and to ensure the compliance with the regulatory requirements, which is 21 CFR Part 820 or 821 for medical device, etc. So that in itself is not new. The life cycle that pertains to life sciences industry may be new for software developers or those in SaaS. Okay, so they talk about a framework and it introduces a distinction between systems used as part of production or quality systems. It directs focus on risk to process, whether it is a production or a quality process that can impact product, patient safety, data integrity, same as we've been used to before. So conduct analysis to determine appropriate assurance activities. Again, that analysis is talking about the risk-based approach. Identify reasonably foreseeable future failures, as opposed to the old traditional kind of FMEA approach where you have to kind of make up these kind of failure modes that you think might apply and might keep people happy when they read this kind of thing. But they talk about reasonably foreseeable software failures. And I think this is one of the key things for me is coming out of this as well, because there's a lot of industry results and information going back many years for a lot of the software tools that we now use as part of testing software now. It's like the Jira, the Jenkins and all that. They're going back a very long time. Not as long in maybe in life science, but in the software industry themselves, those tools are tried and tested for a very long time. They're also considered infrastructure software in places as well. And we also need to look at the scope of intended use. That's critical, or the system boundary when we start to tie a lot of software systems together. They focus on, does a failure pose a high risk? So that's what they're looking at, is for us to focus on those high process risk items, whether it's a risk to a quality process or a manufacturing or production process. Those are the things we need to focus on. And then performing assurance activities commensurate with the process risk as applicable. So the higher the risk, obviously, the more testing you need to do, et cetera. Okay, they talk about systems, first of all, within it, and this, is it used as part of a production process, and is it used as part of a quality system process? So often, software that's used as part of a quality system is lower risk, and that really is being tied to the fact that it's less likely to affect the product, which is in turn less likely to affect the patient. That's not to say that all quality systems fall into that category, but some of them do, and for sure, and some of them are outside of scope if properly risk assessed. And then they talk about, well, what category is it? Is it used directly, or does it support? And again, they make reference that systems that support production processes and quality processes that can impact product and patient safety are less risk. So you have to build up a framework within your risk assessment process to get down to that level of testing or level of assurance that they're talking about within the guidance. So direct, if we say, what would be examples of direct systems? So automating production processes, or inspection or testing, or the collection and processing of production data, or automating software that automates quality system processes, and again, collection and processing of quality system data, or maintaining a quality record established under your quality system regulations, or that are there to meet any regulatory guidelines. And then indirect would be, for example, tools that are used for development tools that test or monitor software systems, or that automate testing activities for the software used as part of production or quality systems, such as those used for developing and running scripts. If we have life science people on here, I'm not sure the mix, but you've used the likes of Neat, Valgenesis, HPALM, those kind of things that are used for testing. So what they're saying is here that those are indirect, low risk type systems. So you're very justified in taking, or what they're saying is that you're justified following a proper risk assessment and saying, we've come to the conclusion that there's less testing involved in this type of system for all the various reasons, et cetera, et cetera. Okay, so high risk. So what type of software features constitute high risk? There's some guidance in the document as well. Examples would be software that maintains process parameters like temperature, pressure, humidity that affect the physical properties of a product or manufacturing process that are identified as essential to device safety or quality. And they're kind of talking about medical device. So CSA is a bit more geared towards medical device, but it does include other manufacturing processes or systems throughout the document. Maintain. So other types of software features would be software features that maintain, such as maintain process parameters. Measure, inspect, analyze, or determine acceptability of product or process with limited or no additional human awareness or review. Okay, so that's kind of important that there's no additional checks on it, so to speak. Software that perform process corrections or adjustments of process parameters based on data monitoring or automated feedback from other process steps without additional human awareness or review. This is a very interesting one because I know from working in the industry for a long time that there's lots of systems that perform data monitoring and get feedback, et cetera, but that automated correction of process parameters or adjustments is very new to the field, and you can understand why there's trepidation towards kind of accepting that last step in the process where the software can make the adjustment and keep the process going or keep it within optimal parameters for manufacturing. But that type of evolution we feel is surely on the way. So software that produce directions for use or other labeling to provide patients and other users that are necessary for safe operation of the medical device. So we're talking about labeling, packaging, that kind of stuff as well. And then software that automates surveillance or trending or tracking of data that the manufacturer identifies as essential to safety and quality. Okay, so that's kind of some of the high-risk software features that are called out within CSA as high-risk features. Then they have features, they identify features that are not high risk. So they specifically say not high risk, they don't say low risk. So what they're saying is they're at a level below what they consider to be high risk. So they talk about software that collects and records data from the process for monitoring and review purposes, no direct impact on production or process performance. Software that's used as part of the QMS for the likes of Kappa routing, Kappa automated logging, tracking of complaints, automated change control management, or automated process procedure management, etc. So you're talking about your Kappa deviation system, your doc management systems, etc., etc., etc. That software that is intended to manage data, so process, store, and/or organize data, automate an existing calculation, increase process monitoring, or provide alerts with an exception when an exception occurs in established processes, and/or are used to support production or the quality system. So software that supports systems as well. And we had that that's kind of referring back to the kind of the indirect. It's clearly stated in CSA that the FDA is primarily concerned with the review and assurance for those software features, functions, and operations that are high process risk, because a failure poses a risk to the product, in turn, a risk to the patient and or data integrity also. So, okay, so what are appropriate assurance activities? So this is a section within the guidance as well on appropriate assurance activities. So management selection, prioritization, and use of testing activities and resources they're consciously based on corresponding types and levels of analyzed risk. We're going back to our risk assessment to determine the appropriate activities. The level of assurance and rigor should be commensurate with the process risk. Heightened risks of software features, functions, or operations generally involve greater rigor or greater testing and a greater amount of objective evidence. And one thing to be that's called out within GAMP, and we'll get to that, not specifically this point later, is they talk, and in CSA as well, about objective evidence is not a screen capture to saying, yeah, I can't actually object with the evidence because I can see it on screen in front of me. And in fact, they're trying to discourage the use of screenshots for proving lots of activity has happened or lots of configuration is as it should be. Remember that objective evidence is a test that's confirmed by somebody, and they put their signature to it to say, yes, I completed this test, and yes, I confirm it's correct as per the test parameters and acceptance criteria, et cetera, et cetera. That is also objective evidence. That's not to say that screen captures are never required, but there's clear guidance within CSA and GAMP that they're not necessarily always required or required at all. They talk about two types of testing, unscripted testing and scripted testing. And again, each is applicable based on the amount or the risk you've associated to a particular parameter or piece of software, etc. So unscripted testing includes ad hoc testing, which does not rely on large amounts of documentation or test procedures to execute. It could involve a spreadsheet in the early days of testing where software engineers are going in and confirming that, yes, this software is functioning exactly as we require it to be. Error guessing, so it's the tester's knowledge of past failures. So we're relying on the experience of the tester here, who are the best people in the world to rely on because they do this software day in, day out. It's their job, it's what they do. And then exploratory testing based on the tester's existing relevant knowledge also. On the other side of that, and probably will likely be linked to more high risk items, is scripted testing. So robust scripted testing, risk of the CS or automation includes evidence of repeatability, traceability to the requirements, and auditability, so that you have that full life cycle evidence available for that particular requirement, shall we say. And then limited scripted testing. So it's a hybrid approach. Scripted and unscripted, appropriately scaled according to risk of the CS or automation, i.e. scripted testing for high risk features and unscripted testing for low to medium risk features. So this is from the guidance. Okay, the next section they talk about is additional controls and mechanisms. I think this section is key within the new guidance, as some items in here are new in how they are presented in regulatory guidance. In my opinion, what they're stating here is that there are other things that you can have in place that, again, reduce the risk and reduce the amount of testing and the type of testing. So when deciding on the appropriate assurance activities, manufacturers should consider whether there are any additional controls or mechanisms in place throughout the system life cycle that may decrease the impact of compromised safety or quality if the failure of the software feature, function, or operation were to occur. So firstly, activities, people, and established processes that provide control in production. Again, this isn't strictly new. It's definitely not new in life science, but it might be places where SaaS companies or software providers need to firm up on around those kind of things. And again, we find that in a lot of the audits we do of SaaS companies is they have good people, good processes, but they're not necessarily well documented, even though the process is good. If they were to just document it somehow and confirm the trainings to happen, it automatically they're much more presentable to life science companies, and life science companies are delighted because they want to use your good software, but sometimes it can be limited if you don't have established processes in place. Selection and monitoring of software developers. Again, this is highlighted in blue because it's kind of linked back into what Oisin was talking about earlier. Leverage practices, leverage the validation work and the life cycle deliverables from the vendor as a starting point. And it comes back to what Oisin said about for life science companies about selecting good vendors, because if they have a good life cycle in place, CSA and GAMP, they're encouraging that you use everything that they have. And I'm not saying to make it fit into your life cycle. It should fit. It should be a good fit. And there may be a delta to improve on a particular deliverable that you can work with the vendor to do. But they talk about working with the vendors to reduce the amount of work and especially around the lower risk items for indirect systems type things as well. They talk about determine what additional activities may be needed, if any. So yeah, so that's no vendor is ever perfect on every aspect of every requirement that you want. So you got to work with the vendors and determine what additional work is required from their side, and if not possible from their side, you'll have to do it as the life science company who's accepting this software. Additional process controls, processes fully understood. All CPPs are monitored, and all outputs of a process undergo verification testing. So what they're saying here is, and it comes back to what it's always said in GAMP, going back many, many years, is good product and process understanding. That's always been the case. But what they want that to translate now into is get those critical quality attributes, know what they are, get those critical process parameters that feed or that contribute to that critical quality attribute. And then within your risk assessment, feed that down, and they become the items that you test fully or ensure that they are fully catered for within your risk assessment process, your testing, your provision of evidence, etc., etc. Data monitoring, periodically, continuously collected and detecting issues. So data monitoring is something that's in a lot of life science companies and within a lot of SaaS providers as well, within their software and within their life cycle as well. What they're saying here now is that this is an additional control within the life cycle. And for me, and I've read through CSA a couple of times, and I'm going to have to go through it a few more times, is what they're saying is that if you have this type of monitoring in place as part of the software, well, then that can be legitimately used and feed into the risk assessment process to determine how you validate and how you maintain the system post release. So that could be your historians and servers that are monitoring data all the time and can automatically notify of parameter changes, etc., or configuration changes, the likes of configuration management software that you would have monitoring HMIs, PLCs, SCADA in the field, etc., etc. The use of computer system validation tools, bug trackers, automated testing for the assurance of software used in production or as part of a quality system wherever possible. So this brings in something that's kind of new to life science, but been in software or the SaaS providers domain for a very long time, or DevOps. So DevOps, and it's reasonably new to someone like me who's been involved in validation of software for life science for a long time. But DevOps, once I started looking into the frameworks that are in place around DevOps, they're very solid, very tried and tested, great evidence, great audit trails. They're there for a long time. They're very robust. But again, SaaS companies, and it brings me back to point one, where they may not have good activities and established processes around the use of DevOps. Even though DevOps is good, you need to kind of put those kind of processes, go that little extra mile to explain it better and control it better, to demonstrate to a life science company that might want to use your SaaS that you're doing that. Oh, excuse me. And that's what we are calling ourselves, a term that we're using called compliant DevOps. So in other words, putting that quality management system wrap around that little extra mile to demonstrate that your DevOps is actually a very well documented, controlled, and managed process from a procedures and people perspective. Because I've looked at DevOps now for the last couple of years. We've expanded to have a software dev team, and it's really, really, really a very good system. But what's lacking in a lot of places potentially is that good processes around how you manage and how you do your DevOps. And then the use of testing done in iterative cycles and continuously throughout the life cycle. Again, that's another point that's in another control mechanism. To me, that talks to, again, DevOps a piece, but also to more agile forms of project execution, which in turn can feed back to that unscripted testing, those sprints that you do, and unscripted, scripted, depending on how closer you get to the point where you're ready to release the system. Okay. Okay, the last portion they talk about is kind of establishing the appropriate record. So what is the appropriate record? Intended use of software feature. So capture sufficient objective evidence to demonstrate that the software features, functions, or operation was assessed and performs as intended. So what does this mean? If you want to leverage from vendors from previous slide around additional control mechanisms, then they need to have this in place from a life cycle perspective. Determine of the risk of the feature, functions, or operations. So bullet point 1 is more about putting requirements in place. So user requirements for that software features, functions, and operation. Bullet point 2 is determination of the risk. We've talked about that already. We execute functional risk assessments looking specifically at software functions. Assurance activities conducted. So in other words, do your testing. And all good testing should have the path it should follow is conduct your testing. If you've issues found, how are they managed? Acceptance of declaration, an acceptance declaration. So in other words, you should have acceptance criteria, and at the end, a declaration that the acceptance criteria was met. Initial and date of your testing, and established review and approval when appropriate. So this language of when appropriate as well. And again, they're talking about the type of system. Is it production or is it quality? The type of category it's in, is it direct or indirect? All this feeds down into your risk assessment and say, well, you know, that feature is very low risk, so I don't need anybody else to review it. You can potentially, this is what they're saying, that review of every single item might not necessarily be required anymore. It's up to you to build a story and tell the story within your life cycle for the software. Again, it's about leveraging from vendors as well. If you're a life science company, the more that a good SaaS vendor is set up in this way, the more you can use. And this is a message to SaaS companies too, that the more you're set up like this, the easier it is for life science companies to adopt what you do. The more they have, the better the quality of it, the more they can leverage. That's really how it's always worked. Okay, so that's kind of it for CSA. I might just jump into GAMP second edition and what they talk about, what they state about suppliers as well. So section 7 in GAMP, it's about suppliers, and we won't have time today to go through lots of it. And I actually haven't read every piece of GAMP second edition as of yet, but there's picking out some salient points around that. You can leverage supplier knowledge and documentation once they're formally assessed. So, and it's back to what Oisin said, supplier assessment as per your defined process. This is nothing new for life science companies. They should be operating within a QMS. That's nothing new. And it should be based, the QMS should be based on a life cycle approach. And they do call out that, as in previous slides, that they do call out that this can absolutely include an agile approach. So if we look at IT service provision, including cloud within the QMS, what they state, these are bullet points clearly called out within GAMP, and they're not an interpretation of what GAMP says. These are, if you go into GAMP second edition, you'll see these for yourselves. Preferably, they work within a QMS. They must work within a QMS, preferably that it's a recognized standard-based QMS, so ISO 9001, 27001, etc., those types. Must demonstrate that there's a process being followed to deliver the software, the process being followed to capture customer requirements, that there's responsibilities within your organization and within your department, within your project teams, including separation of authority, so that it's the same. This concept is standard in life science, no matter what it is, but it might be new within software, that the person who's creating the software and test the software need to be potentially separate people. And again, it can go back to the risk associated with it, etc. But they talk about responsibilities and separation of authority. You must identify deliverables, have good management of your records. And if you have a QMS, again, having a QMS means that you must review the QMS and audit yourselves internally. And again, the life science companies will be expected to audit any software providers or any cloud providers that form part of a software offering. Management of incidents, problems, and non-conformances. You must have a process around that. Approach to continuous improvement. And again, it must be based on the life cycle approach. Okay, they also state the following, that you should confirm the above or see evidence as part of your supplier assessments, that you need to see evidence of this in order to leverage from suppliers. So it's software, hardware management, and control and release. What they're saying is here that you need to have procedures, SOPs or processes covering the following topics: software, hardware management, software control and release, development, change control. So you must demonstrate that you have a process for change control and change management during the life cycle in the development phase. You must use configuration management. There must be traceability from requirements to where something has been captured within configuration within the system, and then ideally where it's tested as well. You must be able to demonstrate your training of staff to those procedures that you've put in place. There's no point in having them if you can't confirm that people are using them and working to them. You must have document record and information management. So in other words, a process around how documents are managed and controlled and go up through the various revisions, et cetera, and then a process around backup and restore. Suppliers. Okay, so if you're using a SaaS supplier for software as part of an audit of the SaaS provider, you should look to see that they in turn have processes for supplier assessment, audit, and in particular that they have assessed suppliers that are involved in the SaaS that you're using. And this term, and it's called out clearly in GAMP, they talk about sub-suppliers. And again, it was less important years ago because there was less sub-suppliers. But as you move into the new world of SaaS and platform as a service as well, the relationships are definitely extending into sub-suppliers. For example, you should confirm who is hosting, as an example, who's hosting the application that you're using. So you may have a software application developed by a software supplier, but somebody else is very likely hosting the application. And it could be the case that somebody else in turn is actually hosting the output data from the application. And then I've seen it in some occasions where a third party is hosting the backup of the system. So it's not unusual, we've seen it. So you need to understand the architecture and the data flow for your systems as well. So with that said, the guidance from GAMP is that suppliers should formally assess their sub-suppliers. They should periodically reassess according to their QMS. Again, we've said that they should have a QMS and they should have a process for supplier auditing. Audit if deemed required. So they're talking about, you should definitely assess them, and then you should audit them if you think, based on the criticality of what they're doing for you, et cetera, it comes back to your risk assessment. And in particular, hosting GXP data, sub-supplier management, this is a direct statement from GAMP, sub-supplier management may have a direct impact on regulated company compliance. So they're saying transparency is key. You need to know who your suppliers, sub-suppliers are, and how they selected them, how they're managing them, and et cetera, how that all is being managed within their QMS. And that's really it for today. Obviously, we could talk for about a few hours on what CSA and what new editions of GAMP also state, but that's it for today. Back to you, Pauline.
Fionnán, thank you so much. I mean, as always, providing us with a really detailed and critical information sharing. It's wonderful that you're putting that out there, getting people insights into these new regulations I should say guidelines that, will take a little bit of time to digest. And so thank you very much for sharing your thoughts thus far and really helping us, helping the whole movement of the adoption of cloud. Now, there's quite a few questions, Fionnán, come through. So I'm going to just go through a couple of them quickly. I'll just give you a couple. I won't ask you them all. Yeah. And then we'll move on to the panel. So what I wanted to put in here is that, let me see, quite last down here. So how much should we adhere to the CSA guidance if not working with medical devices?
You should adhere to it fully because they talk about, I was disappointed when I saw a lot of medical device in there. They seem to push it a bit more, but then again, they throw in production systems, you know, so it doesn't matter if you're in pharma as well. And they do refer out to the original guidance around software validation going back. It's many years old now. I can't think of the actual exact title of it now, but within CSA, they refer back to that software validation guidance that's still valid with them as well. And they talk about this being complementary and supplementary to it, but they talk about production processes as well. It's not all about medical device. It is talking about processes as well, you know.
Okay.
Production processes.
Production processes. Okay, thank you.
And again, I wouldn't ignore it because CSA is giving you a framework to be smarter, to apply critical thinking, to use that risk-based approach, to leverage other factors outside of a system that reduce the risk and reduce the amount of testing, up to the point of where you do very little more than assess your vendor, see the testing they did, and if it's good, adopt it fully and do very little other than that, you know. So okay, I think it's a good thing. So I wouldn't ignore it. I would build it in, you know.
Yeah. And actually, just so you mentioned the critical thinking, I saw a question come in as I've scrolled up to it. It says, I've read in the recent draft and new guidelines about applying critical thinking during my software development lifecycle. What does this mean? I guess, I mean, you touched on it obviously, but maybe just a couple of short lines on what that means.
Yeah, so an example would be applying critical thinking to the software development artifacts that are required to demonstrate traceability of the verification activity against the spec. Okay. As I said, as I was speaking there, it starts with that product and process understanding, you know, but that's always been in GAMP. Okay. But what they want you to go down a little bit more critical thinking within, the product and process understanding relating to critical quality attributes, critical process parameters. And I suppose they're giving you go ahead to say, and again, it kind of relates to ASTM 2500 about verification, whereas that if you identify those things, those are the critical things. This is the critical thinking that you'd apply and say, we are absolutely going to make sure that everything is tested. And we have all very strong evidence around those points. And then as we step back from that to the lower risk items than those, and the lower risk items again, that we build a story and we stick with it, have the right SMEs in the room that say, yes, that's a sensible approach to this software testing for all these reasons. Okay. That's the critical thinking they're looking for, you know? Okay, great. I'll ask you directly one more question, Fionnán. You're nearly off the hot seat, and then I'll bring in the rest of the panel if that's okay. So one last question to you. For CSA tools, what is the minimum level of verification / validation required for a COTS application? Sorry, say that again. For CSA tools? What, yeah, it says for CSA tools, what is the minimum level of verification and validation required for a COTS application? So again, it's called out in CSA that very often there may be no real validation required other than installation of the software and confirmation that the configuration management, that kind of stuff, confirming that the configuration is right for you. But again, it leads back to your vendor as well. So that is dependent on assessment of the vendor, assessment of the approach they did to validate the system, okay, and including assessment of their processes and their SOPs. I said that, are they someone that you can trust to manage it and manage it after that point or during the maintenance phase as called out in GAMP? That's really it. But they do say clearly that it says up to no validation other than that confirming the installation is correct, that recording configuration versions, et cetera, and they're talking about up to no validation. If you're accepting the functionality as it is within the COTS system, you've audited the vendor, and they're very good in all the aspects. And if there's aspects where the vendor are weak that you think that might be weak, well then that needs to go into your testing. For example, if you weren't happy with their security testing, or for whatever reason you wanted additional security testing, by all means, that's what goes in. But it's basically down to the assessment of that vendor.
Great.
Is what they say is key.